podcast is brought to you by TechStreet. Discover simple and smart standards management. Discover TechStreet Enterprise. Well, greetings, everybody, and welcome back to ASME's new podcast, Unconventional Engineering. I'm your host, Roy Firestone, and I'm here with my co-host, ASME's Executive Director and CEO, Tom Costapile. Tom, so great to see you again today.
Roy, it's great. Any day that we can do something together is a great day. I'm reflecting a little bit on our conversation last time with Ian Davis, and I'm excited to see where this one's going to go today.
Thank you, Tom. It's great to be with you. We're going to get right into it. Folks, Tom and I are really very pleased to welcome to today's podcast a man trying to determine if robots really can be self-aware. His name is Mr. Hod Lipson. Welcome, Hod. Hod is originally from Haifa, Israel. He is an American robotics engineer. So thank you for joining us, Hod.
My pleasure.
You know, it's such an amazing story. For those who don't know, Hod Lipson is a professor of engineering and data science at Columbia University in New York, whose works in the areas of robotics and artificial intelligence are lauded. He and his students love designing and building robots that do what you least expect robots to do, and that is self-replicate and self-reflect, ask questions, even be creative. He's an award-winning researcher, teacher, communicator. Hod Lipson also directs the Creative Machines Lab, which pioneers new ways to make machines that create and machines that are creative. Let me start with this, Hod. I know you grew up in Haifa. You developed a fascination, even as a young person, with mechanical engineering. Can you tell us a little bit about your background and what really first interested you in robotics and artificial intelligence?
Well, thank you. First of all, it's a real pleasure to be here. I'm passionate about these topics, written books about them, and I love speaking about these topics and getting people engaged. And for me, it all started as a child. And you know, I never really liked to take things apart to understand how they work and all that stuff. That wasn't me. I'm not a scientist. I'm an engineer. I just like building things. I was obsessed with building forts and building Lego things and building machines that do all kinds of things. And I started my career as an engineer watching, I studied conventional mechanical engineering, and I watched how people were designing things. And I thought there must be a better way to do this. Surely, instead of designing all these machines, how about we design just one machine that can design everything else? So let's go straight for gold. Let's go and design the thing that will design everything for us. Because if we can do that, all bets are off. This thing can maybe think for itself, can design things we can't. After all, we humans are very, very limited in our imagination. So that got me started in this magical combination of mechanical engineering and artificial intelligence.
Wow. Tom, you also have a mechanical engineering background. How do you think robotics, Tom, and AI will impact the future? And can they help to create more jobs?
I truly believe that robotics will create safer jobs and more jobs for the future. Robotics, using robots to do some routine things, and what we used to do way back when I was really practicing engineering in the 70s and 80s, robots are doing it today. My favorite thing to talk about is pipeline inspection, or deep tank, or confined spaces. So where you would put somebody's life in peril in putting them into a large tank, now you put a robot in there. And then my other favorite one is drones. So is a drone a robot? I believe it is. And when you look at it in terms of using that to do inspections, you get a much higher quality of review, a safer environment for people to live in, and more jobs that are out there. So now instead of doing routine work, you've got the scientists, or as Hod said, crazy engineers like himself, creating these little toys that's there. And by the way, Roy, his office, the best toy store you ever want to see. It just is. It's an amazing place. So.
Yeah, no, if I can add to that, a lot of people think, jobs are going to go away, robots are going to replace people, but actually it's not that case. That's not the case for many reasons. One of them is that, let's take, for example, driverless cars, all right? Sure, AI is going to drive your car tomorrow. But because of that, there's going to be more miles driven per capita. That means more car manufacturing, more service, more road construction. Lots of different, the economy is going to grow in lots of different ways. So the robots take a little bit, but they give something back. And it's not that everybody's going to be a software developer, and that's the kind of jobs. No, robots can create lots of jobs in manufacturing and maintenance and technical support and lots of different ways. So I really think we're looking at a general economic growth because of automation, and that's something to keep in mind. We never know the details of how it's going to play out, but I'm pretty sure it's going to lead to growth.
I was going to say there's a lot of disinformation, Hod, and Tom, that you can join us on this subject too, about the myths about what robots. We remember the old science fiction movies. They're going to take over the world. They're going to cost us. There's negative push, right? For both gentlemen, you, Hod, and you, Tom, talk about that society is resistant and scared of robots and AI. Am I right?
Right. Look, there's many reasons for that as well. We can blame Hollywood. We can blame human nature, that we always worry about the dangerous things more than we care about the positive. We lump robots. We see it as one thing that can just do everything we humans do. But really, when you dig in, there's a little bit of nuance to it. Robots are good at certain things. AI is good at certain things, but it's very poor at other things. And when I say it's poor at it really, we as roboticists have no clue how to do certain things. For example, if you look at robotics today, we have no clue how to get robots to manipulate things with the dexterity and grace that humans can.
Like fixing a car. In other words,
like fixing a car. Exactly.
They could tow a car, but they couldn't fix a broken car.
Exactly.
Right?
Like, in Manhattan today, a plumber makes twice as much as a software developer per hour. Why? Because crawling around and fixing things is very difficult to automate, very difficult to offshore, and you need it yesterday. Whereas software development and diagnostics and all these fancy information things, you can sort of do remotely and do automatically and so on. So doing things physically is very, very difficult. This means that anybody who's working in the trades, for example, is going to be irreplaceable for the foreseeable future. This is very different than jobs on an assembly line, which are born to be automated. I mean, they're designed to be repetitive and accurate and very easy to automate. So we can't lump all physical jobs and say all physical jobs are going to be replaced by robots. That's a very gross misconception. And just that nuance is very important when you think about the future.
Hod, tell us a little bit about the Creative Machine Lab to make machines that are more creative. What do you really mean by that? Let's get this started here.
Okay. Well, I was afraid of that question because I don't know what I mean by that exactly. but if you look at sort of these myths around robotics, one thing that people say consistently is, okay, so you can automate everything. Robots can run faster and jump higher, and they can work 24/7, and they're more powerful. But we humans, and you can even make robots that can drive a car and decide whether to turn left or right or whatever, but we humans have a different kind of intelligence. We are creative. We can create new things. And there is nothing more challenging for me than somebody saying, you can't do this. This is off limits. So I said, okay, really? So creativity is the thing? Then I'm going to go for that. And I want to see what is so powerful about creativity, and perhaps we can automate some of it, or at least augment it, because I think that it's not about replacing human creativity. It's about, wouldn't it be awesome if you had software or AI, a robot that could sort of be a partner and tell you, hey, did you think about that? How about we do it this way? How about, just again, expanding our ability to create new things. So we're after this lofty goal of creativity, of creative machines that can imagine new things, solve problems in new way, and also make the things that they imagine. And that touches on 3D printing and all the things you mentioned. So that's what we're after. And we're looking at creativity all the way from, engineering creativity, which I think is very challenging, although a lot of people think that's not creativity, it's music and art. But I think engineering creativity is actually very, very difficult, and in many ways, affects our our lives in more profound ways, all the way to yes, music and art. So
I was going to ask you about that. There is a website called, I think it's Pixel 18. Is that right?
Pix18.
Now, if anyone wants to go to this while they're listening to this broadcast, it's pretty amazing. Computers, software, AI are actually recreating the classic paintings. Anything from Andy Warhol to Rembrandt to Van Gogh. But here's my question. Could it come up with its own, based on its style, its own Rembrandt, its own Van Gogh?
Yes, actually, I was going to correct you there. It is not copying Rembrandt or anybody else. It is coming up with its own things. And it's completely, I know I have no control over this machine. And you can look at it and say, this reminds me of this and that. But really, it's coming up with its own things. And it's inspired by things it saw. It's seeing paintings, it's seeing things in the real world, but it's painting its own things. And to me, it's the story of this is really that I always wanted to paint, but I'm not good at it. But I'm good at building robots. So I thought after I took classes and all kinds of things, and then I said, okay, forget this. I'm just going to build a robot that learns how to paint.
So, Hod, is the robot still hanging on the wall in your apartment?
The robot is on the wall, and so are the paintings. Yeah.
Yeah, good, good. Well, Roy, when we visited and had the opportunity to visit, he's got a couple of exquisite paintings in there. You had to do a double take to understand it, and then the creativity. I don't believe it's going to replace the Rembrandts or the Picassos of the world, but it gets there. It really does, and it's amazing.
It's let's put it this way: it's a new genre. Okay, yeah. Now whether it's nothing replaces anything else when it comes to art.
Well, don't you think though there'll be pushback for that, saying no, humans must create human art. This is artificial art, and it's not legitimate. You'll understand that argument, right?
Yeah, it's look, people said that about Impressionism. They said this is not art. Art is this. Yeah, it's the longest debate in history. What is art? And I'm sure when the first caveman drew, or cave woman drew the paintings on the wall, somebody complained about it, right? I mean, there's always critics, and it's an arms race. It's a tug of war. It's always that tension is always there. But I think it definitely challenges our conception of art, because it's the first time there's an art without a human artist. That has never happened before.
Here's a subject that I think we could talk about for the rest of the day, and that is programming robots to have empathy, feelings. Will robots eventually have the capacity to understand things like fear and feelings, and be able to develop real relationship? You saw that movie Her with Joaquin Phoenix. He falls in love with AI. Do you believe a machine can really be self-aware, and can it develop a real interpersonal relationship with a human being?
Yes, I believe the short answer is yes, but this is very controversial. So this is a minefield, and before we go in there, everybody should prepare. People have very strong feelings about this, because after I talk about creativity, people say, okay, you can argue about creativity, but how about feelings? This is always the next thing. Okay, so robots could be creative. We'll grant you that, but can a machine have feelings? And we know machines can detect feelings and they can fake feelings, but can they have feelings? And this is a really, really subtle point, but very, very important. And I think the answer is yes. And it goes into, and it's not going to happen tomorrow. And it's not, it doesn't mean they're going to take over the world. But machines can have feelings, and they can certainly engage people with feelings. So your question about Her, again, is a little bit nuanced, because in that movie, they did not suggest that machine itself had feelings, just that it could manipulate the feelings of the human. And that's a lower bar. So I think that is absolutely within reach, and that's going to happen in the next decade or two.
Do you think, big question, it can love?
Yeah.
AI can love, legitimately, sincerely love, not pre-programmed to
Yeah,
love.
yeah, that's right. So it can have feelings. Now, are these going to be human feelings? No, it's going to be slightly different feelings. It's going to be just like a dog has feelings, but they're not human feelings. They are dog feelings, and they are very powerful, and dogs are very emotional, but it's not one-to-one with humans.
Mhm.
So dogs feels about food differently than humans feel about food, most people. So I think that in general, machines will have feelings, but they will be very, very different. Because, for example, this is a very unromantic description, but feelings are nothing but predictions about oneself in the future, in the short term and in the long term. So we can have short-term feelings like fear, or glee or something like that, or we can have long-term feelings that have to do with predictions of success or anxiety or so on. These are all basically predictions about the future, our own future. And we are sort of able to simulate ourselves into the future. So that's what emotions and feelings are. They are simulations about the future involving ourselves.
So, Hod, in a similar vein, your opinion about can AI help us address issues of diversity, equity, and inclusion?
Oh, that's such a hard question. I think, yeah, it can help us, but in the end of the day, it's a tool. And how we use it is going to be up to us. I mean, we definitely can use it to bring a lot more people in to the conversation. We can use it to engage more people. We can give access to a lot more people. When you have an app that can do diagnostic on a phone that's better than a team of experts, that means that you have increased access to healthcare to the entire planet. That is a huge drive for equity and inclusion.
I would
Now,
agree with, I would agree with you.
that's gonna change. That's gonna give people access to things they've never gotten before. When you can do education using AI that reaches more people, reaches all people around the planet and places that don't necessarily have access to the best teachers, that's an incredibly empowering thing. So I think in that way, AI can help us do things. But again, we have to decide that that's how we're going to use the software, and this is where we're going to put the effort.
I want to ask one question of both Tom and you, Hod. First, Tom, what concerns you, Tom, about AI in the future and robots, et cetera?
Well, that's a good question, Roy. I'll tell you again, in relationship to a seminar I just attended about the ethics of AI. And one of the presenters there started to talk about the programming, the logic of autonomous vehicles. So an autonomous vehicle is driving down the street. It sees that there's an accident, and to avoid the accident, it would have to swerve to the side and possibly hit a pedestrian. How do you program that into the intelligence factor of the vehicle? And then the ability to use that with cyber attacks. What is a cyber attack? A cyber attack is basically the unethical part of using AI. So those are the issues that we as a society, a global society, are going to have to come about.
What do you think?
Well, I'm glad you asked Tom first, because that gave me a chance to think about what I'm going to say there. But you asked about what am I worried about? I am very worried about what Tom mentioned, basically our vulnerability to cyber attacks. The more we rely on robots and AI, and other things, we are becoming vulnerable, and there's not enough appreciation of that vulnerability. So, in part because it's invisible. People understand bombs, and they understand terrorism, and they understand nuclear, but it's very difficult to understand what a cyber attack does. But when it wipes out your bank account, it's very visceral. Okay, so we have to really understand that this is as bad as other things. It's just very abstract. And I'm worried about that, but I'm also worried about sort of AI, disrupting social structures by, for example, talking to humans and all the things we discuss. And that's a little bit more long-term, but it's coming.
But Roy, I wanted to go to something else that Hod has developed, because again, when I went to his office, or the greatest toy store in the world, I saw something with he's done with open source 3D printing, as well as electronic 3D printing, bioprinting, food printing.
Wow.
I want Hod, tell us, in your opinion, the best applications of 3D printing, and please talk a little bit about printing food.
Food printing. I never heard
Food
of that. Food printing.
3D printers are about manufacturing, and I think that most people don't manufacture anything at home except food. So you think about it, how many people have a workshop where they spend their weekends making stuff? A lucky few, I would like to think, but everybody has a kitchen, everybody's making food. So we have a factory in our kitchen, and it is only natural that if you're going to make a machine that can make anything, a 3D printer, it's eventually going to end up in the kitchen. That's, to me, a very logical conclusion. We talk about food also, but we start, 3D printing, just like AI, is one of these technologies that are universal. They can worm themselves into anything. It's not just about 3D printing plastic tchotchkes or printing, aerospace parts. 3D printers can make anything from printing food to printing implants, biological implants, printing electronics. And, a lot of people tell me, 3D printers, it was hype. It went up in 2015 and now it's not, but actually that's not it's the contrary. If you look at the curves of adoption of additive manufacturing, 3D printing, they are exponential. They keep growing at 20-30% per year in terms of the growth of the industry. We're seeing 3D printers worm their way into more and more industries, but I think we haven't even seen the tip of the iceberg, because 3D printers right now print in single materials mostly. They print a metal part or plastic, but once 3D printers can print in multiple materials simultaneously, plastic and metals at the same time, electronics, food, all these different materials all at the same time, at that point, you can really start making all kinds of things. You can make integrated systems rather than simple parts. And again, combined with AI and customization and optimization, now you can start making really things that you can't even begin to imagine today. So for me, 3D printers are sort of the missing link.
Tom, you wanted to talk about student members.
Thank you. Thank you, Roy. Anytime that I can talk about students and engineering education is a great day. But Hod, you've worked your career with students, first at Cornell and now at Columbia. Tell us all, how does working with students inspire you and your work?
Well, I don't even know where to start. But the beautiful things about students is that they come in they're not jaded, they're not pessimistic, they come in with an open mind and an enthusiasm for creating new things that you cannot get anywhere else. And I've worked in industry and I've worked in other places, and this is an incredible energy that you get from students. So all we have to do in university is just open the smorgasbord of tools and ideas. The appetite just takes over, and all the creations and all these toys you mentioned in my lab, they're all created by students. In fact, most of them undergraduates coming out of high school and suddenly making all kinds of crazy things, and then the rest is history.
I would agree with you. And again, the part that's amazing is that as the generation that's currently in grade school, they'll be working on those issues that we haven't even touched on yet, but they'll have the skill sets and they'll have the ability to take the intelligence that's been developed so far and bring it not to the next level, but bring it up 10 more levels. It's amazing.
Well, hopefully we'll be around to see it, Tom and Hod, but I don't know if we will. But bottom line is,
we'll make a robot out of you, and that robot.
Yeah, I was going to say. Hey, Hod, thank you for taking the time to be with us today. And thanks to you both for a great conversation.
Thank you.
Well, that does it for this episode of ASME's Unconventional Engineering. Special thanks to my co-host, ASME Executive Director and CEO, Tom Costabile. Thanks also to all of you for listening in. We want to know what you think, and we love to hear your suggestions for potential future topics and guests. So reach out to anybody on the Unconventional Engineering Production Team, or send your email directly to media@asme.org. And to become an ASME member, please log on to asme.org, or to donate to the ASME Foundation, go to asmefoundation.org. For ASME, I'm Roy Firestone. Have a great day, everybody.